Hello everyone, and first of all, I wish every one of you a warm, sweet, and crazy happy Christmas. And today we will do the Feynman's technique for integration, and we will integrate this guy from 0 to infinity and the arctangent x over x times 1 plus x squared. And this little x makes the whole integral very troublesome, because if we don't have this x, we can use a direct substitution to solve this problem. But now the x is here, so we will use another method, which is the Feynman's technique. So let's get started. Well, first of all, we need to define our integral. So I will define the integral as a function of t. So I will insert the t into the arctangent x, because we know that differentiate arctangent x will give us 1 over 1 plus x squared. So we hopefully also, by the chain rule, we can cancel out the x in the denominator. So now I will define this integral as like this, and then we will differentiate this integral with respect to t, and as the derivative goes inside the integral, it will become a partial derivative. So we'll have a partial derivative with respect to t, and then I will copy the integral again. Okay, now we need to be careful, because now we are differentiate with respect to t. So I will move all the things not related to t to the front, which is 1 over x times 1 plus x squared. And then now I will differentiate this guy with respect to t. So we will treat x as a constant. So now we have 1 over 1 plus tx whole square, because we differentiate arctangent tx, multiplied by x, because of the very famous chain rule. Yeah. Okay, and a dx. So now we are happy, because this x is automatically cancelled out. So now we are living as the product of two fractions, and we need to do a partial fraction. So let's do the job. Partial fraction, I write it down. Okay, yes. So now I will split the fraction. Okay, I copy it again. I multiply out t squared x squared multiply by 1 plus x squared. So I will split the fraction into two parts, which is these two expressions. And for the numerator, we need to assume it is a linear factor. So I will let x plus b, as I Cantonese, and cx plus d. Okay. So now we will do the cross multiplication. X plus b plus multiplied by 1 plus x squared plus cx plus d, and then 1 plus t squared x squared. Okay, I will leave the denominator because it's the same as the left hand side. So I will multiply it, all the things out. So I will multiply these two terms first to arrange as a descending power of x, which is ax cubed plus bx squared plus ax plus b, which is the first product. And then for the second product, we plus t squared cx cubed plus t square dx squared plus cx plus d. Wow, so many, but it's okay. I use highlight pen. For the cube, the x cube term, we know that a plus t square c is equal to 0 because there's no x cube term on the left. So I will write all the coefficient out. B plus t square d equals 0, a plus c equals 0, and b plus d equals 1 because it is the constant term here, b plus d. So now the first and the third equation, I will subtract them to eliminate the a. So we know that t square c minus c will be 0. So it makes c equals 0. And then a is also equal to 0 by the third equation. So for the second equation, the second and the fourth one, I will also subtract t squared d minus d, which is equal to minus 1. So d will be equal to minus 1 over t squared minus 1. Well, this makes... Whoop, I don't have space. Okay. There are lots of Christmas decoration. So we will know that b will be equal to 1 minus negative 1 over t squared minus 1, which is t squared over t squared minus 1. This is good. So now we can split the integral. Okay, let me have some space here. So we know that our I dash t will now be equals to integrate from 0 to infinity, and then we will put the coefficient in it, t squared over t squared minus 1 over 1 plus t squared x squared plus minus 1 over t squared minus 1 over the big denominator 1 plus x squared dx. So now we will integrate this guy, and notice that we are integrating with respect to x. So now we move all the things irrelevant to x outside, which is the 1 over t squared minus 1. And then we integrate from 0 to infinity t squared over 1 plus t squared. Okay, I will factorize this guy like this, and then minus 1 over 1 plus x squared dx. So now we can integrate them one by one, and then we know that if we integrate tx, so we can use a simple substitution, u equals tx. So we will generate a constant. I will copy the t square here, and then we will have a 1 over t because of the substitution, and we will have the arctangent tx. So now this guy will have the limit infinity and 0 minus, and the next one is simple and is arctangent x. Of course, it's from 0 to infinity. So we will now cancel out 1t here, and then we will leave the 1 over t squared minus 1 outside, and then we will substitute the limit. So arctangent infinity is equal to pi over 2. So we will multiply t by pi over 2 minus t multiplied by the arctangent of 0. So it is also 0. And then we will minus, we add the bracket, pi over 2 minus 0. We close the bracket like this. So now we will have 1 over t squared minus 1. And then inside the bracket we have t times pi over 2 minus pi over 2. So now I will factorize the pi over 2 outside. And then it is multiplied by 1 over t squared minus 1 and then t minus 1. And then notice that the denominator, we can factorize it into t minus 1 and t plus 1. So these two factors will cancel out. And we will have pi over 2 times t plus 1. And this is very nice now. Oh, sorry. It should be in the denominator. Oh. Okay. I'm too happy for the Christmas. Nearly have a mistake. Okay. We'll get some space here. So now our integral will be equal to, we integrate 1 over t plus 1 times pi over 2 with respect to t. So now I will move pi over 2, the constant, outside, and we integrate 1 over t plus 1 is very simple, which is ln t plus 1 plus a integration constant c. So how do we find this integration constant? So how about we consider the case for t equals 0. So we know that the integral of 0. So we put 0 into the t. And we know that if we put 0 here, then the arctangent 0 is also 0. Then the whole integral becomes 0, right? So now we know that I0 is equal to 0. So now we also put the t as the 0. So now we have pi over 2 ln 0 plus 1, which is also 0, plus c. So the integration constant is 0. So now we have our result. The integral is equal to pi over 2 times ln t plus 1. So this is the general formula, and we simply substitute t equals 1, and then we can get the value of our integral as pi over 2 times ln 2, and we finish our question. And thank you for all for watching my video, and I wish you again a Merry Christmas. I will see you in the next video. Bye bye.